Hello students, I hope all of you are doing well. So in this video, we will be revising kinematics motion in 1D chapter. All the topics, your concepts, formulas we will see in this video, right? Let us start. Okay, so let us start. So in this chapter, we have these following topics. If we see the topics that we have: distance and displacement, speed, velocity, acceleration. So basically, what is this motion in 1D all about? Motion in 1D or motion in general, kinematics in general is about your studying the motion of a body, of an object. We study motion of an object using some motion parameters. What are motion parameters? Physical quantities which help us in understanding the motion. For example, distance, displacement, speed, velocity, acceleration, right? So first of all, we will look at all these quantities and then go into the detailing of it. So distance, displacement, speed, velocity. In speed and velocity, we will discuss speed average, velocity average, instantaneous speed and velocity. Then acceleration. In acceleration, what all we will be discussing in acceleration? Uniformly accelerated motion when acceleration is constant, which basically is all about your equation of motion. Then we have motion under gravity, that is 1D motion in vertical, right, which is under motion under gravity. Then we have non-uniform acceleration, that is when acceleration is varying. These are the questions, most of the variable, basically your calculus based questions, differentiation and integration is involved, which comes under your non-uniform acceleration. And finally, we have graphs. In graph, we discuss about your position time graph, velocity time graph, acceleration time graph, and how to analyze motion using the graphs, right? So let us start. The first, if we see distance and displacement. Distance and displacement. If we talk about distance, all of us understand distance is basically the length of the actual path traveled by a body. Distance is the length of the actual path traveled by a body, right? Let's say it starts from A and it reaches to B. So the length of actual path is your distance. It is a scalar quantity. It is a scalar quantity. That means it only has magnitude and its unit is, SI unit is meter. Fine, right? Next, if we talk about displacement, what is displacement? Displacement is basically the shortest distance between initial and final position. The shortest distance between initial and final position is your displacement, right? Displacement, shortest distance, it is generally denoted by S. It is generally denoted by S, and it is a vector quantity. It is a vector quantity and its SI unit is again meter. Fine. This is about your displacement. Now, if we talk about, let's say that a particle is moving in X direction. Displacement, I said the definition that it is the shortest distance between your initial and final position. Now, if we talk about mathematically, let's say that a particle is moving in X direction and initially, if a particle is moving in X direction and initially its position is x1 comma 0 and it moves to a position of x2 comma 0, then how do we write down your displacement? Displacement will be delta x, which will be equals to final position minus initial position, x2 minus x1. This is motion in 1D, right? If I talk about, let's say, if we have to write it vectorially, if we have to write it displacement vectorially, let's say that a particle is present at a point P which is having a position vector of r1, right? And later on it moves to a point Q which has a position vector of r2. So initially particle is present at a point P and finally it reaches to point Q. What path it has taken right now, we are not focusing on it, because displacement is all about your initial and final position. Displacement is all about initial and final position, so not focusing on the path, right? So let's say the particle is initially at P point and finally it moves to Q point. Then displacement is what? The shortest distance between initial and final position. this displacement S I am denoting by delta R. Why delta R? If the position vector of initial point is R1 and position vector of final point is R2, then displacement in vector terms delta R can be written as final position vector minus initial position vector, right? R2 vector minus R1 vector. I hope this part is okay. Let us look at the next physical quantity, that is your speed and velocity. Now, if we talk about speed as a physical quantity, what do we understand by speed? Speed is basically the distance traveled by time. Speed is distance traveled by time, right? Now, it may happen that a body may not move with same speed, that is constant speed. Over a period of time, its speed changes. Then in that case, we write down your average speed, and speed average is given as total distance by total time. Speed average is given as total distance by total time. Now, I'll take an example and try to explain this, or will elaborate on this. Let's suppose that a body is moving with a speed of v1 for x1 distance. It moves with a speed of v1 for x1 distance. For next x2 distance, it moves with a speed of v2. It moves with a speed of v2, right? Now in this case, if we have to, because the velocity, sorry, because the speed is changing, speed average, if we have to write down, what will be your speed average? Speed average will be total distance. Total distance is x1 plus x2. Total time taken over here for the first part of the journey, if I have to write down time, it will be your distance by speed, that is your x1 by v1. For the second part of the journey, for x2 distance, if time taken we have to write t2, it will be x2 by v2. So over here, speed average, total distance by total time will be t1 plus t2, which we can write as x1 by v1 plus x2 by v2. Now many a times, many questions you will come across where they have given that x1 and x2 are equal. Let's suppose if the x1 and x2 value are equal, the distance traveled is equal. So in that case, if you see, if x1 is equals to x2, which is equals to x, what can we write down? So speed average will be x1 plus x plus x2 x by, this will become your x by v1 plus x by v2. So we will get over here v1 plus v2, x will come common, this goes over here in numerator, v1 v2. Ultimately we get 2v1 v2 by v1 plus v2. You can keep the result in mind, or it's very easy to derive it, or you have to solve it. So not a very big deal. This is your speed average when a particle is traveling for equal distances, for two equal distances with different speeds v1 and v2, then this is the speed average, right? Let us look at the next parameter, that is your velocity. Yeah. So up till now, we have discussed about your distance and displacement and speed and velocity. The next physical quantity that we'll be discussing is acceleration. So let us see. Acceleration A. What is acceleration? Acceleration is basically your rate of change of velocity. It is defined as delta V by delta T. Acceleration is rate of change of velocity, delta V by delta T. It is a vector quantity. It is a vector quantity and its direction is along the direction of change of velocity. Its acceleration direction is in the direction of change of velocity, and the SI unit of acceleration is meter per second square. Right now, if we talk about your instantaneous acceleration instantaneous, right? So acceleration instantaneous is given as dv by dt. Acceleration instantaneous is dv by dt. This we can also write it as d square x by dt square, d square x by dt square. Now this is your variation of, that means your differentiation of velocity with respect to time. When we have velocity as a function of time, then we can find out acceleration as dv by dt. What if velocity is given as a function of x? If velocity is given as a function of x, then also we can find out your acceleration. How? So in this relation only, if we see, if we write down dv by dt is there, if we look at it mathematically, dx and dx, so this dx by dt is basically what? V, velocity. Dx by dt is velocity. So acceleration, therefore one more relation that we get is acceleration can be given as this dx by dt is your what? Velocity V, and dv by dx. So these two relations for your accelerations are important. One is dv by dt, another is your v dv by dx, right? Now let us look at the next. We will be discussing about your how acceleration and velocity are related. That means what effect acceleration has on your velocity. Let us take a look. Now, as we have seen that acceleration is rate of change of velocity. Whenever velocity will change, acceleration will be there. Now, if we take a look, if I take certain cases, let's suppose a body is there and it has a velocity v towards positive x direction, and its acceleration is also towards positive x direction, right? Then what will be the effect on this body? The velocity of body will increase. The velocity will increase. That means, or to be precise, the speed of the body will increase. The magnitude of velocity will increase, right? If we talk about, if let's suppose it has a velocity towards positive x direction and acceleration is towards negative x direction, when velocity and acceleration are in opposite direction, this acceleration is termed as your retardation. This is termed as your retardation or deceleration. This one is your positive acceleration. This is positive acceleration. Most of the time you will not hear positive acceleration. They will not write in the question or theory. Acceleration, we take it this only. But retardation is when acceleration is opposite to the velocity. Then what it does? It decreases the magnitude of velocity. It decreases the magnitude of velocity. Then if let's suppose your velocity is there towards positive x direction and acceleration is perpendicular to the velocity. If acceleration is perpendicular to the velocity, then in this case, at this moment, velocity magnitude will not increase, it will not decrease, it will change the direction of the motion. It will change the direction of motion. So whenever acceleration is perpendicular to velocity, direction of motion changes. Direction of motion changes whenever A is perpendicular to V, right? So this is some. We have discussed about your how velocity and acceleration are related. Now also, as we know that velocity and acceleration both are vector quantities. Both are vector quantities, that means they have direction also. For them we assign the positive and negative sign. Positive and negative sign. So what is our general convention? The general convention is, if we talk about sign convention, if we talk about sign convention, general convention is that in horizontal towards positive x side we take plus sign, towards negative side we take minus sign. In vertical direction, if I talk about, above upward it will be taken as positive, downward it will be taken as negative, right? Now this is our general sign convention that is being used, right, in horizontal direction and in vertical direction. Now this should not be confused, the negative minus a should not be confused with retardation. What I am trying to say over here is, let's suppose that a block is there of mass m and it is moving with a velocity of, if it is moving with a velocity of minus 2 meter per second and acceleration is also minus 5 meter per second. It is given to you like this, right, that this is 2 I cap, let's take 2 I cap, and acceleration is also 2 I cap, minus 5 I cap, 1 minute, minus 5 I cap meter per second. Now meter per second square. So velocity we have taken as minus 2 I cap meter per second, acceleration minus 5 I cap meter per second. Now this negative sign of acceleration should not be confused with your retardation. To decide whether it is positive acceleration or retardation, we should look with velocity. Now what is velocity? Minus 2 I cap means, that means it is towards negative x direction. Velocity of the block is towards negative x direction, and acceleration is also minus 5 I cap, that means acceleration is also in this direction. Now if you will notice that velocity and acceleration both are in same direction, as velocity and acceleration both are in same direction, or I should say acceleration is towards velocity, then in this case the magnitude of velocity will increase, and therefore this will act as a positive acceleration, or I should say this will increase the speed of velocity. It will act as acceleration for it. Negative does not mean it is always retardation, है ना? So this is the thing. This is about how acceleration affects velocity, and over here I have talked about when we say negative acceleration, or over here minus 5 meter per second is the velocity, that means it is towards negative side. When we are saying acceleration, motion under gravity, acceleration due to gravity, when we say g value is minus 10 meter per second square, what do we mean by minus 10 meter per second square? It means that g is acting in downward direction. If velocity is downward, then this g will act as acceleration for it. If velocity is upward, this g will act as your retardation for it. So I hope this part is clear, right? So we are done with the introductory part of acceleration. Now we will look at your acceleration is about your change in velocity. Acceleration is about your change in velocity. Now acceleration can be uniform acceleration, it can be non-uniform acceleration. Uniform acceleration is when a is constant, right, and when your non-uniform acceleration is when a varies, when acceleration varies. So first of all we will be looking at your uniform accelerated motion. So let us see. Okay, uniformly accelerated motion, that is when a is constant, when a is constant. Now this is an interesting case, many questions you will find from this section itself. So acceleration constant, there are some equations which we term as equation of motion, which gives us relation between initial velocity, final velocity, acceleration and time. What is our equation of motion? What are the equation of motion we have? V is equals to u plus at, s is equals to ut plus half at square, v square is equals to u square plus 2as, right? Also we have one more equation which gives us displacement in nth second. We have one more equation which gives us displacement in nth second. In that particular second, what is the displacement? What is our relation? Sn, this is displacement in nth second, is u plus a by 2 2n minus 1, right? Now these are our equation of motion. One thing that I would like to highlight or point out for this is that over here all these equations are valid when your acceleration is constant. All these equations are valid when acceleration is constant. one thing I would like to highlight is about your displacement. This S is displacement. This S is displacement. All these equations are basically for your vector quantities. This is velocity, final velocity, initial velocity, acceleration. This is time. So displacement, it's S is displacement. In some cases, when a particle is moving in a straight line in one direction only, in that case, distance will be equals to displacement. That's a specific case. But otherwise, we need to be careful that this S is your displacement of the particle, right? In these equation. Fine. These are our equation of motion. Next, if we take a look at one of the cases of this, which are, if we can remember the result, it's very helpful. Let's suppose a situation is given to you. Let's say a car is there, which is moving with a speed of u. And it is given to you that the brakes are applied and it gets a retardation of a. If it gets retardation, that means a will be opposite to velocity, right? So after how much distance the car will stop? So let's say the car will travel a distance of x. Let's say that the car travels distance x before stopping. Stopping means basically v will become 0. So which equation we can use over here for this? V square equals to u square plus 2s. V square finally 0, u square plus 2a. Acceleration, it was said that it is retarding with a, that means it is opposite to velocity, so it will come out to be minus a into s. So what is our s value coming? It will be your u square by 2a. So x, the distance traveled by the car before stopping is u square by 2a, right? This is one of the cases we can remember, one of the result we can keep in mind. Fine, let us move ahead. Next, we are looking at your motion under gravity. Let us see. Okay, so if we look at our motion under gravity, what is motion under gravity? Motion under gravity is basically your motion in 1D. It's a straight line motion which is happening in vertical direction, and as it says motion under gravity, in this the particle experiences an acceleration g downward. All the objects are being attracted near to the surface. All the objects get attracted with the acceleration of g, and that g value is 9.81 meter per second square. Most of the time for calculation purpose we take it as 10. Now over here, for small distances, that means near to the surface of earth in motion under gravity, we consider this g value as constant, and therefore we can use all our equation of motion over here also. What all our equation of motion are? That is v is equals to u minus gt, s is equals to ut minus half gt square, v square is equals to u square minus 2gs, right? All these equation of motion that we have seen can be used in motion under gravity, where acceleration is constant. It is 10 in downward direction, right? Now there are some special cases that we should keep in mind regarding your from motion under gravity. What are those special cases? So let's suppose case 1, when a particle is thrown up with the initial velocity of u. Let's say a particle is thrown up with the initial velocity of u. Now, if a particle is thrown up with initial velocity u, what will happen? It moves up, it is experiencing g downward. That means g will act as retardation. So it will go up, its velocity will decrease, and at the highest point its speed will become 0. How much time it will take to reach at the highest point? This time we term it as time of ascent, and this is given as time of ascent is u by g. It can be easily calculated using our first equation of motion, v equals to u minus gt. So time of ascent, the time taken by a particle to reach at the highest point, is u by g, right? In this journey, if it is thrown up with a u speed, it will reach to a maximum height where its speed will become 0, and this maximum height h is given as h max is given as u square by 2g. It is given as u square by 2g. This relation is calculated using this third equation of motion, right? Again, the particle will reach at a height h and then finally it will fall down. The time taken by the particle to come down, that is termed as time of descent, and time of descent is given as again u by g. Time taken by particle to go up, time taken by particle to come down are equal, and their magnitudes that we have is u by g. Right, this is what we have. Also, we can remember one more thing in this, that if a particle is thrown up with a speed u, it will reach at the topmost point, speed becomes 0, and when it returns back over here, its speed will again be u only, obviously in downward direction. Velocity will be minus u, but speed will be your u only in downward direction, right? So these are the results that we can keep in mind, which will be helpful when a particle is thrown up from ground. Fine. Next result that we should have in mind is when a particle is dropped from a height h. What I am trying to say is, let's suppose if from height h a particle is dropped, released, that means initial velocity is 0. So there are two results that we should have in mind. The first result is about your time of flight. The first result is time of flight. What do we mean by time of flight? Time of flight is basically time taken by particle to come down. Time of flight will be root over 2h by g. Time of flight is root over 2h by g. Now this result is calculated using second equation of motion. This result is calculated using second equation of motion. We have to keep the results in mind. This is anyways a formula revision video, है ना? So t is equals to time of flight is root over 2h by g. Next, if we talk about, because a particle is dropped, it is coming down, g is downward, that means its velocity increases, and its velocity increases just before hitting the ground. Just before hitting the ground, if we see, the magnitude of velocity will be root over 2gh. Just before hitting the ground, velocity will be root over 2gh. At any time also we can write down the velocity. Let's suppose if h distance, if it travels h distance downward, then time can be written as root over 2h by g, and speed after traveling a distance h can be given as your root over 2gh. Okay, these are the results that we should keep in mind. Acha, over here one more result I will add it. Time of flight. Over here for the previous one that we have discussed, time of flight. Time of ascent is u by g, time of descent is u by g. So time of flight, that is total time for the journey, will be your 2u by g. Right? These are two of the very standard cases that you will come across in motion under gravity. So if we keep these results in mind, they are very helpful. Next, if we take a look, next one more, if I say, let's say if a particle is thrown up from a building of height h, thrown up or thrown down. I'll take both the cases. Let's suppose a particle is thrown up, okay, with a speed of u, and then it moves up and then comes down. Let's say they ask you find out the time taken to reach at the bottom. How to deal with it? Now, if you will notice, this is the initial position of particle and this is the final position of particle, right? In vertical, what is the displacement? In vertical, displacement is nothing but h only. Moved up, came down. So basically in this, the displacement is your h only, the height of the building. So we can use our equation of motion, which is second equation of motion. We can write down minus h is equals to ut. I am writing over here, minus h is equals to ut minus half gt square. Now see carefully over here, look at the signs. minus h. I have used minus h. Why minus h? Because the final position is below initial position. That's why I have used minus h over here. U is taken positive because the particle is thrown upwards, and G is obviously downward, right? If we want to calculate time. Similarly, if let's suppose a case is given to you where they say that a particle is thrown down with a speed of u. A particle is thrown down with a speed of u, then what is the time taken by particle to come down? So in this journey also, this is the initial position, this is the final position. How much is the displacement? Displacement is equals to height of the building only. So what can we write it? Minus h is equals to minus h. Why minus h? Because it is downward, final position is downward, is equals to minus ut. Why I am using minus u over here? Because it is thrown downward, initial velocity is downward, minus half gt square. Using this, you can calculate the time taken by particle to come down. Now, important, let's see that we should keep this in mind, that this result that we have done, t equals to root over 2h by g, this result is valid only when the initial velocity is 0, when a particle is dropped. When initial velocity is 0, that means particle is dropped or particle is released. It will not be valid when a particle is thrown down, right? You can't use that relation. For that, you will have to go with this only, because you will be there in that case, right? So these are some of the cases that you can keep in mind for dealing with motion under gravity, right? Now let us look at some our next, which is your non-uniform acceleration, the differentiation integration cases. Let us see. So next we will talk about your non-uniformly accelerated motion. There you will come across questions where your acceleration is varying. Now in those cases, our equation of motion will not be helpful. We will have to take help of differentiation and integration. So what we are talking about basically, let's suppose x as a function of t is given to you. Let's suppose x as a function of t is given to you. I'll take an example. Let's suppose x is equals to t cube plus 2t square plus 1. Right? X as a function, the position or displacement is given as a function of time t. So if we want to find out velocity, what we'll be doing is, velocity as a function of time t, velocity we know is dx by dt. That means we will be differentiating it, right? Next, if velocity as a function of time t is given to you and we want to find out your x as a function of time t, then we will have to integrate it. How? So dx is equals to v dt, and therefore we can write integral dx is equals to integral v dt. So to get xt, from xt velocity time equation, we will have to differentiate from velocity time. If we want xt, x as a function of t, we will have to integrate it. Fine. Now once you get your velocity time, I'll take this example that I have taken, x as a function of time t, velocity. What will be our velocity? Dx by dt. If we do dx by dt, it will come out to be 3t square plus 4t plus 0. So 3t square plus 4t. Now you have velocity as a function of time t. You have velocity as a function of time t to calculate acceleration as a function of time t. To get an equation which gives us acceleration as a function of time t, what we will have to do? We'll have to differentiate it. Why? Because acceleration is dv by dt. Acceleration is dv by dt. Once, or if you have acceleration as a function of time t, so I am talking in reverse. If you have acceleration as a function of time t and you want velocity as a function of time t, then you will have to integrate it. How? So dv can be written as a dt. So velocity as a function of time t, we will get it by integrating acceleration function. Okay, this is what we have got. For example, velocity 3t square plus 4t. So a will be dv by dt. dv by dt over here will come out to be 6t plus 4, right? As you can see that acceleration is varying with time. So this is the case we have. So from xt, from, if we have position as a function of time t, we want velocity as a function of time t, we'll have to differentiate it. If velocity as a function of time t we have, to get acceleration we'll have to differentiate it. Reverse, from acceleration time, if we want velocity time, we'll have to integrate acceleration function. If we have velocity function, we want to find out your position or displacement function, we'll have to integrate velocity function, right? So this is the thing that you can keep in mind. Okay, apart from this, one more result that we should keep in mind is, if velocity is given to you as a function of x, if velocity is given to you as a function of x, that means basically vx, v as a function of x is given to you. So in that case, we want to find out acceleration. So what result we'll be using? Acceleration is v dv by dx. Acceleration is v dv by dx. Many a times this result is also very helpful. So v dv by dx, right? So these are the results, and this is what we will have to use, apply when your some acceleration is varying, or a function is given, that means a physical quantity, position or velocity is given as a function of time t, then we'll have to deal with them in this manner, right? Let us move ahead. Now we have come to our last topic, which is your graphs. Xt graph, velocity time graph and acceleration time graph. Let us see. Yeah, so let us talk about graphs. First of all, graph, if we talk about, let's take first, which is your xt graph. Xt graph, position time graph or displacement time graph. Let's say a situation is given, x and t, right? Something like this is given to you, a straight line curve is given. First of all, what does xt graph give us? What information does displacement time or position time graph gives us? Your xt graph, that means slope of xt graph gives velocity. Slope of xt graph gives velocity. This should be very clear in our minds, that slope of xt graph gives us velocity. At any particular point, if it's a straight line, the slope will be constant. If it's a curve, at any particular point, if we draw a tangent to that point, the slope of that tangent, it will give us the velocity at that particular time. Let us see some of the standard cases of your xt graph. Some of the standard cases, if we take a look, let's say your this, in this case, as you notice, if position time graph is given to us, it is not changing with time. That means basically what is happening? Particle is at rest. Over here, particle is at rest. Velocity is 0. Velocity is 0. You can also see this line, this graph is your parallel to time axis. That implies slope 0, that means velocity 0. Next, if let's say we have this situation, the one that I drew earlier also. So xt graph. Now over here, what do we see? It's a straight line. It's a straight line with a positive slope. It's a straight line with a positive slope. That implies your positive slope, that means velocity is positive, that means it is towards positive x direction if the motion is happening in x direction. Second thing, as it is your straight line, the slope is constant. Slope is constant, that means velocity positive and constant. Velocity positive and constant, as it's a straight line. If velocity constant, we can also say that acceleration will be 0. Fine. Let's see. Let's consider this. In this case, what do we see? We have a xt graph, which is a curve. Xt graph, which is a curve. Now, in this case, if we look at how do we find out the slope? Slope over here is, if we take 2 points, point A and point B. So, we will have to draw tangents at point A and B. We have to draw tangents at point A and B. And if we look at the slope of these tangents, you will notice first thing, First thing, that the slope of the tangents is increasing. If the slope is increasing, that implies your velocity is increasing. Some information. First, what is our basic? Slope of xt graph gives velocity. Slope of xt graph gives velocity. So over here, first thing, slope positive or negative? Slope is positive. That means velocity is positive. Second thing, is slope constant or changing? Slope is changing and slope is increasing. Slope is changing and slope is increasing. That implies your velocity is increasing. Over here, velocity is increasing. That implies acceleration is there. Right? This is the xt graph that we have seen. Fine. Let us look at our next, which is your velocity time graph. Yeah. So velocity time graph. First of all, let us take a look what information do we get from velocity time graph. Two things that we should keep in mind. First, slope of velocity time graph gives acceleration. Slope of Vt gives acceleration. First thing. Second, area under Vt curve, gives displacement. Area under Vt curve gives displacement. If I talk about it, let's take a situation where over here the velocity time graph is given to us something like this. This is what is our velocity time graph given to us. Now over here, what will we have? So the slope will be giving us the idea about acceleration, and the area under velocity time graph will give us idea about displacement, right? So in this case, if I take, this will be your positive displacement S1, and this one, the below one, will be your negative displacement minus S or minus. Yeah, so let us look at the different Vt graphs. Let's suppose we have like this. So over here, as you can see, velocity is constant with time and the slope is 0. That implies your acceleration is 0 over here. Next, if we draw, let's say a straight line is given to you which passes through the origin. What information we can talk about your acceleration? Because the slope is constant and it is positive, that means acceleration is constant and positive. Over here, as it starts from origin, it passes through the origin, that implies your u value is 0. Next to it, if we draw, let's suppose Vt, if we draw like this, okay, in this case, what can we say? Acceleration, slope is constant, it is positive, that means acceleration constant and positive, but over here velocity time graph does not passes through origin. That implies it has some initial speed. This will be your u. Okay, let us look at some other curve. So again, your Vt curve is given to you. It's a straight line with a negative slope. What does this mean? It means negative slope, that means it's retardation. Negative slope means it is retardation over here, because velocity is positive and acceleration is negative. Slope negative, acceleration negative, velocity is positive. That means it is retarding. So retardation over here, and it's a constant retardation. It is a constant retardation. Why I am saying constant retardation? Because the slope is constant. The angle is constant over here, right? So that is why. Next, if we take a look, let's suppose we have a curve. We have a velocity time curve. It is given to you as something like this. Now, first thing, is slope positive or negative? Let us take a look. If we draw any two tangents, slope is positive. That means acceleration is positive. Is slope constant or changing? Slope is changing. As you can see, theta 1, theta 2, angle increases, slope increases. That means slope is changing and it is increasing. So acceleration is positive and increasing. That implies this is the case of your non-uniform accelerated motion. This was the case of your uniformly accelerated or uniformly retarding motion. These two were the cases of uniformly accelerated motion. So this is our non-uniformly accelerated motion where acceleration is positive and it is increasing. Next, if we see one more, if I have to draw it for you, let's say VT curve is given to you, something like this. Okay. In this case, is the slope positive or negative? Is the slope positive or negative? If we notice, slope is positive, right? Slope is positive, but what is happening is slope is positive but it is decreasing. Slope is positive but it is decreasing. That means acceleration, velocity is increasing in this case. It's an acceleration only, but the rate of change of velocity is decreasing. The rate of change of velocity is decreasing in this case, right? So all these different cases are there about your velocity time graph. Now, in all these cases, I have talked mostly about acceleration. I have talked about slope and acceleration. How do we find out area and what about your distance and displacement? So let me take a situation. Let's suppose we have a velocity time graph. Something like this is given to us, right? Something like this is given to us. As we mentioned that area under VT graph gives us displacement. So this area under velocity time graph will give us displacement. This displacement, positive displacement plus S1. This is your negative displacement minus S2. So let us be clear, whenever you have to calculate displacement, from velocity time graph, it will be area above minus area below. So if I say this is area A1, this is area A2, whenever you have to calculate displacement from velocity time graph, it is area above minus area below. Why minus? Because the below it is negative displacement. It is returning back towards its original path, hai na? Or towards its initial position. So we can write down displacement will be in area above minus area below. Whereas if we talk about distance traveled from velocity time graph, distance traveled will be area above plus area below, A1 plus A2. So this is the information that you should remember for calculating distance and displacement from velocity time graph, right? So let us see, the last that we have is your acceleration time graph. Yeah, if we talk about acceleration time graph, so what we have is AT graph, acceleration time graph. What information does it give? So let's suppose we have this acceleration time graph. What is our knowledge? Knowledge is that V is, or I can write acceleration is dV by dt, right? Acceleration is dV by dt. So dV will be a dt, right? If we want to find out velocity from acceleration, we have to integrate your acceleration function. So we can get delta V is equals to integral a dt. Now what information do we get? That area under, because integral a dt in terms of graph is what? Area under the AT curve. So area under, area gives change in velocity. Please be careful, it is not velocity, it is not just velocity. So area gives what? Change in velocity. That means V final minus V initial. Area from acceleration time graph, area under acceleration time graph gives us change in velocity, that is delta V, right? Fine. So with this we have discussed all the concept and formulas from your motion in 1D. I hope you found the video helpful. If you liked it, do consider to press the like button. Thank you very much. Bye bye.